All right, today we're diving into something really new and exciting, a new way to understand our incredibly complex economies. It's this powerful combination of artificial intelligence and classic economics, a method that promises to solve problems that, honestly, until now, have been pretty much unsolvable.
So it really all starts with this one big question. Why is it so hard for economists to build a model that actually looks like the real world? Well, the thing is, our economy isn't just a few simple buttons and levers. It's this giant, tangled web of millions of people, different risks, and complex behaviors. And trying to model all of that, that is a huge challenge. And this gets right to the heart of the problem. It's something called the curse of dimensionality. Just imagine you're building an economic model. You start by adding one variable, say for productivity shocks. Easy enough, right? But then you add one for financial risk, and then different kinds of households. And with every single new piece you add, the computer power you need to solve it doesn't just add up, it explodes. It multiplies exponentially. And very, very quickly, you just hit a wall.
So economists have been stuck with this really frustrating trade-off. On one side, you've got these simple models. Yeah, they're easy to solve, but they miss all the crucial messy details, like how a financial crisis really happens. And on the other side, you've got these super complex, realistic models that are for all practical purposes just impossible to actually compute.
But what if you didn't have to choose? What if there was a way to get all the realism from those complex models, but with the solvability of the simple ones? Well, that's the big idea we're going to unpack today.
So how do we actually do it? This brand new approach, coming from a working paper by the Bank for International Settlements, is called Generative Economic Modeling, and it's so smart because it combines the raw power of AI with the time-tested methods of traditional economics.
The authors put it perfectly. They describe it as a way to merge the strengths of both of these worlds. So, instead of having the AI try to figure out the entire economic puzzle from scratch, which can get pretty unstable, they use it in a much more strategic, targeted way.
To really get our heads around how this works, let's use an analogy. Let's say you want to train an AI, we'll call it our master chef, to cook a huge 20-course banquet. That banquet is our super complex economic model. Now, trying to teach it to cook the entire thing all at once, it's just too hard. So, you break it down.
And that brings us to the recipe. It's a three-step process that's actually really elegant and, as you'll see, incredibly powerful.
Now, what's really cool about this slide is how it lays everything out. First, instead of that giant banquet, you have the chef cook lots of simpler individual dishes. In our world, these are submodels, smaller, solvable economic models that each focus on just one or two things. Step 2, you take all the data from these simple cooking sessions and you put it all together into one massive cookbook, a flavor library, if you will. And finally, step 3, you have the master chef, our neural network, study that cookbook. It learns all the underlying principles and patterns from all those simple dishes combined.
And here is where the magic happens. After learning from all those simple individual parts, the AI can then generate a recipe for the entire grand banquet, the full, complex economic model. It can actually predict how all these different economic shocks interact, even though it never actually saw them all happen at the same time during its training. And that's exactly why it's called generative modeling.
Okay, this all sounds great in theory, right? But the big question is, does the food actually taste good? Is the final model accurate? Well, the researchers put this to the test.
First, they did something really smart. They ran a controlled experiment. They used their method on a simple model where they already knew the exact correct answer. That way, they could measure precisely how well their AI chef was able to replicate the real recipe.
And the results were fantastic. You can see it on this chart, which shows the error rate. The generative method's error was incredibly low, almost exactly the same as an AI that was trained directly on the full, complex model. And, critically, it was way more accurate than just using one of those simple submodels by itself. It really learned how to put the pieces together into a coherent whole.
And that really gets to the key insight from their test. The neural network wasn't just, memorizing the different parts. It was actually learning the underlying rules. It was generating behavior that made sense for the full system using only the simple building blocks it was given.
Okay, so it works in the lab. That's great. But what's the real payoff here? Well, the team then applied this method to a problem that has been a huge headache for economists for years: modeling financial crises. They basically unleashed their method on what's called a high-dimensional HANK model. HANK stands for Heterogeneous Agent New Keynesian, which is a mouthful. But it's just a sophisticated model that includes different kinds of households and financial constraints. The very things you need to study inequality and crises. And because of that curse of dimensionality we talked about, this type of model was pretty much considered impossible to solve until now.
So what did they find? Something absolutely fascinating. The model showed these really strong nonlinear effects. As you can see here, a small financial shock, yeah, it causes a downturn, just like you'd expect. But a slightly larger shock doesn't just cause a slightly larger downturn. No, its impact is disproportionately worse.
What this uncovers is a tipping point dynamic. There's a threshold where things suddenly get much, much worse. This is exactly the kind of thing that happens in the real world, and it's something that those simpler, linear models are totally blind to. It's absolutely vital for understanding how a small problem can suddenly cascade into a full-blown financial crisis.
But the model also gave them another really counterintuitive insight. What happens when you add more general risks into the economy, like uncertainty about monetary policy? Now, you'd think that would make things more fragile, right? But the model showed the exact opposite. The presence of these other risks actually made households want to save more, just in case. And that made the whole economy better insured and, surprisingly, less reactive when a specific financial shock finally did hit.
So after seeing all of this, let's just step back for a second and ask, why is this such a big deal? What are the real takeaways here?
Well, first, it gives economists a powerful new tool to finally tame that curse of dimensionality, which lets them build much richer, more realistic models. Second, it's a stable, reliable hybrid approach. It avoids a lot of the pitfalls of just using pure AI. And most importantly, as we just saw, it unlocks genuinely new insights into things like tipping points and risk, helping us get a much better picture of how our economy really behaves under pressure.
This really feels like it's opening up a whole new frontier. By combining the best of human-designed models with the incredible generative power of AI, we're starting to solve problems that were once just considered intractable. And it really makes you wonder, if this is what's possible today, what economic mysteries are we finally going to be able to unravel tomorrow?